Welcome to our online chemistry class. Myself, Untitled Chapter from SSPMS and Junior College, Shivajinagar, New 5. Our today's topic is Introduction to Polymer Chemistry. In this part, we have to discuss classification of polymers. In this part, we have to see the introduction first. Polymers. Polymers are macromolecules. Macro means large, having high molecular weight near about 10 raised to 3 to 10 raised to 7. So that compound is called as polymer. This polymer compound can be obtained from monomers, and these monomers having small repeating units. So the compounds which can be obtained by combining small repeating unit to form big molecule or large molecule having high molecular mass, that compound is called as polymer, and the process is called as polymerization. So why the word is polymer? Poly means many and mer means part or unit. So it is a Greek word. So what is monomers? Monomers are small simple molecules having capacity to form chemical bond with two other monomers. For example, protein, DNA, nail, hair, PVC pipe, plastic, raincoat, tire, carpet, polythene. These are some examples of polymer. All of you familiar with the polythene, and it is obtained when ethene is used as a monomer. CH2 double bond CH2. If we take n number of molecules, it undergo polymerization. So CH2 group of first ethene molecule combine with CH2 of second ethene molecule, and the group get repeated is dash CH2 CH2 dash. That group is known as repeating unit, and it form CH2 CH2 n times, and that compound is polythene. Simply you have to use the word poly before the monomer word, that gives a polymer. Now next is, if you observe this diagram, monomers means small unit and they link together to form long chain type of structure, then that is nothing but polymer. The process is polymerization. Now these are some examples of different polymers which are used in our day-to-day life. Now next is the classification of polymers. So polymers are classified on the basis of first source or origin. Then in this type, how we obtain that polymer depends on their origin or source, they can be classified. Second is, what is the structure of that polymer, on that basis we can classify them. Then third is how these polymers can be prepared, that means mode of formation or preparation. Next one is the which different types of intermolecular forces are present in that polymer, on that basis we can classify them. The next type is how that polymer can be obtained or how that polymer chain can be grown, and on that basis the growth polymerization is the base. Then next is the which different types of monomers are involved during the formation of that polymer, on that basis we can classify them. And last one is the biodegradability. whether that polymer can degrade or not. On that basis we can classify them. So these are the different bases of polymers. Let us discuss one by one. Classification based on source. So first type is natural polymers. These polymers are obtained either from plants or animals. Plants and animals are natural source or origin, and on that basis the natural polymers can be further named as plant polymers. Example is cotton, linen and jute. So here you can observe the jute bag as an example of this. Then another subtype is animal polymers, when the polymer is obtained from animal like silkworm. Then the polymer is the silk one, and another example is wool. Okay, so this is about the natural polymer, their sources from nature. Then the second type is the properties of natural polymers are modified or improved by some chemical treatment, and these modified properties are in the form of their appearance, tensile strength and luster. So we can improve these properties, and such polymers are called as semi-synthetic polymer. They are natural one, but few properties which are not good in natural way, they can be improvised in this type of polymers, and they are called as semi-synthetic. So example is acetate rayon, viscose rayon, Kipra ammonium silk. These are few examples of this type. And third type is synthetic polymer. Synthetic polymers are totally man-made and are prepared in laboratories or industries from different chemical substances. So on the basis of their nature, they can be further classified. First one is plastic. So all are familiar with the polythene bags or PVC pipes. These are under the heading of plastic type of synthetic polymer. Second type is fibers. So all are familiar with the ropes, and they are made up of from nylon type of fiber. So this is the second subtype of synthetic polymer. Third one is the rubber. So all of you familiar with the different rubber balls which are used in different games, and they are synthetic rubbers. So the examples are nylon, terylene, neoprene and polythene. These are totally man-made, so they are called as synthetic polymers. So their origin is in the lab or laboratory or industry. So this is about the first type of classification of polymers. Let us discuss the classification of polymers on the basis of structure of polymer. So first type is linear polymer. They are made up of long continuous chain without any excess attachment or branches. The repeating units are joined together to form a long chain type of structure. So let us discuss the example polythene. So ethene, if we take n molecules, it undergo polymerization to form CH2-CH2 n times polythene. So if we observe this structure of polythene, all the atoms or the groups, they are in single chain or long, they form a long continuous chain. There is no branches. Such a polymer is called as linear polymers. If there are branches in your structure, then the another type is present, and that is branched polymer. These polymers consist of chain structure having one main chain of molecule with small chain as a branches of main chain, and they have low density. For example, if you observe polypropylene, The propylene is CH3CH double bond CH2. The CH2 group of first molecule combined with CH group of second molecule, and the repeating unit is CH3CH-CH2. So here CH3 acts as a branch and it will give a polypropylene. So the CH3 does not participate in the bonding, it remains as a side chain or branch. So that's why this type of polymer is called as branch polymer. Then next type is network or cross-link polymers. Linking of chain polymers by strong covalent bond leads to network-like structure. As structure is cross-link type and cross-link is present in your structure, they are also known as cross-link polymers. So if you observe the reaction, when sulfur is added to cis-1,4 polyisoprene chain. So here we can observe the sulfur is added in between the carbon of two molecules of this compound, and there is a carbon sulfur carbon linkage. So here sulfur links the two molecules together and it forms a cross linked structure. So it forms vulcanized rubber. So here network type of structure is obtained and that's why it is called as network or cross-link polymers. So in March 2015 the question is explain with example branched and linear polymers. Here this question is for 2 marks. There is no need to write the reaction, simply you have to write the type of class with example. Okay. Next classification of polymer is based on polymerization process. How polymer can be obtained, which is the process. First one is addition polymers. The monomers are alkene and polymers are formed by chain growth polymerization. So monomers get added together. So addition polymers contain all the atoms of monomer. So for example, when acrylonitrile or vinyl cyanide undergo polymerization, the repeating unit is dash CH2 CH CN remain as a branch group and it will form dash CH2 CN n times. So the compound is Orlon. So monomers get added. Or another example is CF2 double bond CF2. If we take n molecules of this tetrafluoroethylene which acts as a monomer, the repeating unit is CF2 dash CF2 and it will produce dash CF2 n times. Your compound is Teflon. So this is linear polymer, but the monomers get added, that's why it is called as addition polymer. The second type is condensation polymerization. These polymers are formed by combination of two monomers, but the monomers are not simply added, but this polymerization is due to by elimination of small molecules like water or methyl alcohol. So in these polymers there may be a ester dash C double bond O dash O or amide dash CO NH type of linkage in this polymer, and it is a step growth polymerization, or the polymers are called as step growth polymer. Example is polyamide, or the particular example is nylons. Another example is polyester. Example is terylene, polyurethanes. These are some examples of condensation polymerization. The next one is the ring opening polymerization. So it is a process by addition of single monomer unit to growing chain molecules, and it is also a step growth polymerization. So for example, one molecule like lactams, cyclic ethers or lactones, they are involved. So let us see the example: polymerization of epsilon caprolactam to give nylon 6 polymer. So if you observe this compound epsilon caprolactam, CO carbon is the first carbon, next to that is alpha carbon, then beta, then gamma, then delta, and then epsilon. So next to epsilon carbon, the NH group present in your ring, and when we break the bond between CO and NH by adding water at 533 to 543 Kelvin, the ring get open. Okay, that's why it is known as ring opening polymerization. And the compound form is dash NH CH2 5 times CO, and if we take n number of molecules of this, we get nylon 6 as a polymer. In this polymer, CO NH type of linkage is present. So after this, again same group get repeated. So CO and then NH CH2 5 times CO, again NH CH2 5 times CO. So here amide type of linkage is present, so it is a polyamide type of polymer. So this is a ring opening polymer, ring of that monomers get open. Next type of classification is based on intermolecular forces. So the properties of polymers depends on molecular forces. Which are the different types of molecular forces that bind the polymer chain? They are: first one is hydrogen bonding, and second one is wall-to-wall type of force. And due to this type of intermolecular forces, the polymers are further classified as: first one, elastomers. So elastomers are the polymers. They shows elasticity. They are soft in nature. They are stretchy. The reason behind is that the van-der-Waals force. Due to this elastic nature, and if you apply the force, the tearing of that polymer is prevented. The reason is there is a crosslink type of structure in your polymer, and that's why it is used in making the rubber bands. Then the example of this type is neoprene vulcanized rubber Buna S, Buna N. Then second type is fibers. Fibers have high tensile strength. The reason behind that is due to the hydrogen bonding and strong dipole-dipole forces. Here in that fiber, one of the atom is the hydrogen, and it combined with more electronegative atom of another element such as fluorine or chlorine, that means halogens or more electronegative atoms. And due to this high tensile strength, it is used in textile industries. It is also used to prepare strong ropes, tire cords, etc. So for example, this polyamide polymers nylon 66 is used to prepare strong ropes and tire cords, while the polyester, that is terylene or decron, is used to prepare the clothes that is used in textile industry. Then third type is thermoplastic. So these polymers can be easily shaped, molded and recycled. Their properties are in between elastomers and fibers. The reason behind that is they have moderately strong intermolecular forces. The forces of this type of polymer is in between of elastomers and fibers. And these polymers, they become soft when on heating, but they becomes hard on cooling. They are either branch or linear type. Examples are polyvinyls, polythenes, polystyrene. So the word thermo means heat. Okay. The next type of polymer is thermosetting polymers. So on heating, they cannot be soft like your thermoplastic and cannot be remolded or recycled. They are cross-linked polymers, and it is due to the covalent bonds formed in the mold during hardening when they are hot. So these polymers are different than thermoplastic. So they get set on heating. That's why their name is thermosetting. Example is bakelite. Another example of these thermosetting polymers are urea formaldehyde resin. Detail about this we will discuss later on. Then next type of classification is based on growth polymerization. So we already discussed the addition polymers and condensation polymers when we discuss the process of polymerization. So chain growth by addition across the double bond. Example is polythene. Here alkenes are mainly used when they are treated with suitable initiator. So it is a chain growth polymerization. Then second type of polymer is condensation polymer. So during the polymerization, water or ethanol type of molecules are removed and they are step growth polymerization. Example is dacron or terylene. So these polymers can be grown in stepwise manner. The next type of classification is based on different types of monomer which are used during the polymerization. So on that basis, the first type is homopolymer. So monomers having same type of repeating unit, that is known as homopolymer. They having same structure. So in some cases the monomer is identical molecules, such as if monomer is ethylene, your polymer is polythene. If monomer is styrene, then your polymer is polystyrene. If monomer is acrylonitrile, polymer is polyacrylonitrile. If your monomer is vinyl chloride, then your polymer is polyvinyl chloride, that is PVC. If monomer is isobutylene, then polymer is polyisobutylene. If monomer is epsilon caprolactam, then polymer is nylon 6. But sometimes the repeating unit is formed by condensation of two distinct monomers. But even though they are homopolymer, so example is during the formation of nylon 6,6, the monomers are hexamethylene diammonium adipate. This compound is not available as it is. To prepare this, the hexamethylene diamine react with adipic acid and it form a salt, that is hexamethylene diamine adipate, okay, which undergo condensation to gives nylon 6,6. So we have to take two different molecules that gives a hexamethylene diamine adipate. So even though we take two molecules, but they gives a salt which acts as a monomer, and that's why it is of homopolymer type. It is not heteropolymer. Then another example is heteropolymers or copolymers. Hetero means different, so multiple units of each monomers are involved. They are having two or more types of repeating units, and that's why it is called as heteropolymers. They are formed by polymerization of two or more different types of monomers in presence of each other. Different monomer units are randomly arranged in the copolymer. Example is pterylene, buna N, buna S. So in buna S type of polymer, the 1,3-butadiene and styrene, these two different types of monomers, they get combined together, they get added, and they form a polymer, that is butadiene styrene copolymer, or it is also known as styrene butadiene rubber, or buna S is the compound. Then the one more example is ABS type of plastic. So here acrylonitrile, then butadiene and styrene, these are the monomers which get involved to form this ABS plastic. Acrylonitrile, butadiene, styrene polymer. Okay. Next type of classification is based on biodegradability. On the basis of biodegradability, we can classify the polymers into first biodegradable polymers. So these polymers may be natural one and they can be affected by microbes, they can be degraded. But the another type of polymers are non-biodegradable polymers. These are mainly synthetic polymers and they cannot be affected by microbes. These polymers cannot be degraded. So these non-biodegradable polymers stay in the environment for long time as solid waste material and they can cause pollution hazards. Hence, need to develop biodegradable synthetic polymers which are environmentally friendly. So examples are PHBB, polyhydroxybutyrate co-beta hydroxyvalerate. This type of polymer is the synthetic one, but it is biodegradable and it is obtained when 3-hydroxybutanic acid combined with 3-hydroxypentonic acid. The another example is dextron, and it is obtained by a combination of lactic acid with glycolic acid. This is also a biodegradable synthetic polymer. Then third type is when glycine and epsilon amino caproic acid, when they combine by addition of water, they gives nylon 2 nylon 6 type of polymer. So all these above three mentioned polymers, they can be degraded by bacteria, and that's why they are used in orthopedic devices, implants and sutures. So in March 2015, the question is, what are biodegradable polymers and non-biodegradable polymers? Write one example of each. So this is about the classification of polymers. Thank you. My YouTube channel is Mukesh Kharge. If you like this video, you can subscribe and share. In our next part, we'll discuss these polymers in detail. Keep watching. Thank you very much.